So when you rationalize the denominator, your goal is to get rid of the radical in the denominator because a radical is not rational. In the case of monomial denominators that are radicals, if you had something like 20 over root 18, then you have to eliminate that radical in the bottom, and you could at this point multiply the top and the bottom by root 18, which would be the rule. But I think it would be wiser for you to simplify this first. Root 18 is root 9 root 2, so that gives you 20 over 3 root 2. Can you divide the 20 and the 3? Well, you could, but it doesn't divide neatly without invoking other fractions or decimals, so you wouldn't do that. But now you can multiply top and bottom by root 2. And what we end up with on the top is 20 root 2. On the bottom, you end up with 3 times 2, because root 2 times root 2 is 2. I suppose you could multiply the 3 by the 2 to get 6, or you could just cancel the 2 right now out of the 10. Regardless, 20 over 6 is the same as 10 over 3, so this would be 10 root 2 over 3, and you would be done. What changed yesterday, so you do need to know how to do that, what changed yesterday is how do you rationalize a denominator where you have a binomial. And I'm going to pick on one of the harder ones to begin with. Let's just go right to, let's do 3c. No. Let's do an even more difficult one. Let's do 4d together. So what you would want to do here, let's rewrite the question. 3 root 5 minus 2 root 3. It's divided by 3 root 5 plus 2 root 3. By the way, it's a fluke in this question that it's 2 root 3 on the top and the bottom and 3 root 5 on the top and the bottom. It doesn't have to be that way. You would multiply, so this is the rule that we learned yesterday, the top and the bottom by the conjugate of the denominator, which would be 3 root 5. If I can get my colors going here, 3 root 5 minus 2 root 3. And you have to multiply the top and the bottom by that. So remember, a conjugate is identical to the binomial, except if the binomial had plus in between the terms, the conjugate has minus. If the binomial had minus in between the terms, the conjugate has plus. So you're going to FOIL out the top. 3 root 5 times 3 root 5 is 9 times 5. Go slow if you need to. 3 times 3 is 9. Root 5 times root 5 is 5. My outer is 3 times negative 2, which is negative 6, and I have a root 5 times a root 3, which is root 15. My inner is also going to be a negative 6 root 15. And my last is negative times negative. 2 times 2 is 4. Root 3 times root 3 is 3. I want to point out something here. It's not really always relevant, but you know how on the bottom we're just going to go, instead of FOIL, we're going to FLA it? We're going to go the first and the last, because the outer and inner are equal but opposite. When your two binomials are the same, like they are on the top, your outer and inner are equal. My outer on the top is negative 6 root 15. My inner on the top is negative 6 root 15. But when we multiply the conjugates, we can just take the 3 times 3, which is 9, times root 5, which is 5, and we subtract 2 root 3 times 2 root 3, which is 4 times 3. So what do we get? On the top, we have 45 plus 12, 57. Thank you. We have 57 minus 12 root 15. Just making a little mental note to myself that root 15 is not simplifiable. I mean, at some point I'm going to have to address that anyway. I'm going to have to ask myself if I can break 15 up into a perfect square. On the bottom, I have 45 minus 12. Is that 33? Thank you. So now you run through all of your checklist items. Are the radicals out of the denominator? Sure. Are any radicals that are there simplifiable? No. Can I divide any radicals by radicals? No. Can I divide any coefficients by coefficients? Well, that depends if we have a factor on the top that's equal to a factor on the bottom. 57 is a weird number. When I first look at it, I go, I don't think that divides by anything. But I think 3 goes into 57 19 times. So, and I know that many of you see that since 57 is divisible by 3, and 12 is divisible by 3, and 33 is divisible by 3, then factoring to cancel is going to lead somewhere. It's going to give us something that we can work with. 57 divided by 3. So I'm factoring the 3 out, and I have 19 minus 4 root 15 left. This is over 33. And I'm actually not going to write 33. It's over 3 times 11. You do not have to write this if I gave this to you on a quiz, say. But I'm doing it to point out to you again, the only time you can cancel something is if it's a factor. And why is something a factor? Something is a factor because it's in brackets being multiplied by everything afterwards or before. So the 3's do in fact cancel. And you're left with 19 minus 4 root 15 over 11. Any questions from the work? Just take a minute and look over your work, please. Go ahead, Seamus. 5A. Simplify by rationalizing the denominator, so we have 3 over 2 root x plus 3. We are going to rationalize the denominator by multiplying the top and the bottom by the conjugate of the denominator, which would be 2 root x minus 3. I'm glad you asked about this one. When we simplify the bottom, we flood out or FOIL it out, whatever you want to call it, in order to eliminate the radical. And we're going to get 2 root x times 2 root x, which will be 4, multiplied by x, because it's root x times root x. This is the bottom. And then we have 3 times negative 3, which is negative 3. Now, at this level, when 9, thank you. That's, you know what? That's what I'm talking about. That you can, and that isn't a mistake. That isn't a way mistake. That isn't a mistake that I would normally make. I did something that I think students will do. That sometimes you, like with the x, root x times root x is just x. I know 3 times 3 is 9. But I get caught in that radical thing, and I sometimes write 3. Be careful with that. Okay, thank you for the correction, though. Now, over here, on the top of this question that I chose to illustrate what we did yesterday, I actually FOILed out the top. And you can't take anything I tell you as being an absolute rule. And I've told you in the past, don't bother multiplying out the top here. And there's a reason for that. The reason is that 3 is a factor of the top, so maybe I can cancel it with a 3 if 3 is a factor of the bottom. Okay. However, in the previous example, I don't want to just leave these two things multiplied together because I can't see if there is a factor on the top. And it turned out there was, right? There was a 3. So when you're multiplying binomials by binomials, you should multiply it out. Anything else, you should probably leave it. Anyway, this is where we are at. And I really want to drive this home. On the top of this expression, we have two factors. Okay, and I'm going to highlight them for you. But I cannot factor 2 root x minus 3. There's no common factor there. So on the top of this expression, where everything is factored, I have 2 factors, 2 things being multiplied together. On the bottom of this expression, I have 4x minus 9, which I can't factor. So even though there's 2 terms in that, there is 1 factor. So the question I have is, can we cancel anything? No, because there's no factor on the top that's identical to a factor on the bottom. That's the answer as far as I'm concerned, Seamus. If you wanted to, could we multiply this 3 through? Since it doesn't cancel, I guess we could, and we could get 6 root x minus 9 over 4x minus 9. But again, nothing cancels. You can't, we can't at this level start doing silly things like that. That just doesn't fly. It's not right. Does that answer your question, Seamus? Okay. Other questions? Go ahead, Lynette. 4B. All right, so we have 2 root 6 minus root 3 over 3 root 3 plus root 6. And even just rewriting the question, just like I said yesterday, at this level when you're doing math, every step you do, you should do twice to make sure. And I don't always follow that rule, but you should double check things. 2 root 6 minus root 3 over 3 root 3 plus root 6. I need to multiply the top and the bottom by the conjugate of the bottom, which would be 3 root 3 minus root 6. The bottom, when I multiply out the bottom, I'm going to just do the FLA thing. I don't need to do the outer and inner. So 3 times 3 is 9, times root 3 is 3. And then I have root 6 times negative root 6, which will be negative 6. So I'm going to get 21, I think, on the bottom when I work out what 3 times 9 minus 6 is. On the top, I actually have 4 products to do here. I have first, outer, inner, and last. 2 root 6 times 3 root 3 is 6 root 18, because 2 times 3 is 6, and root 6 times root 3 is root 18. My outer is going to be 2 times negative 1, which is negative 2, multiplied by root 6 multiplied by root 6. Root 6 times root 6 is 6. My inner is negative 1 times 3, which is negative 3. And then I have a root 3 times root 3, which is merely 3. My last is negative 1 times negative 1, which is positive 1. Root 3 times root 6, which is root 18. And that is, there's a lot going on there. There's a lot of numbers. Numbers being multiplied by numbers, radicals being multiplied by radicals. I want to double check my 4 products. And you should be doing the same. 6 root 18, and then I have minus 3 times 3, and I also have minus 2 times 6, and I have plus root 18. I think it's fine. I have 2 terms that are root 18s. They add up to 7 root 18, because I have 6 plus the 1 over here on the right. And then I can do this, negative 12 and negative 9 is negative 21, I think. over 21. Oh, that's great. I can cancel the 21s. No, I can't cancel the 21s. 21 is not a factor of the top. Can I simplify anything? By the way, I could factor a 7 out right now. But root 18 needs to be cleaned up as well. And I like cleaning up these radicals at this point rather than later. I want to be clear here. I wouldn't clean them up here. I wouldn't simplify each of the root 18s up there because then you're doing it twice. Bring them together. Root 18 is 3 root 2. So we have 7 times 3 root 2 minus 21 over 21. Wow. We end up with 21 root 2 minus 21 all over 21. I'm really hoping the answer is root 2 minus 1. Better be. Okay. And the reason is, I mean, I know a lot of you just cancel all the 21s, and I'm fine with that. You don't need to show that work. But again, in trying to train you for the next unit, which can really be a steep hill to climb for many students, factor then cancel. So 21 is a factor of the bottom, 21 is a factor of the top, and you're left with root 2 minus 1. Is that okay? Okay. Any other questions? Yep. 5C. So root k plus 2 over root k minus 2. I guess I'm going to have to multiply here, Reagan, by the conjugate of the bottom, which would be root k plus 2. Because we learned again, and this gets repetitive, but we learned that when you multiply two binomial conjugates, basically you get the square of the first minus the square of the second, so any radicals would disappear. On the bottom, I'm going to get k minus 4, because root... Did I write something down wrong? Is it root 2 as well? Yeah. Oh, it is. Okay. Thank you. So these are all roots as well. Okay. So on the bottom, I'm not going to get k minus 4. I'm going to get k minus 2, because root k times root k is k. And minus root 2 times positive root 2 is minus 2. On the top, we have to actually FOIL this out. So I'm going to get the first, which is root k times root k, which is only k. My outer is root k times 2. I would probably write it as root 2k. My inner is also going to be a root 2k. And my last is plus 2, because root 2 times root 2 is 2. I don't think there's going to be anything we can really do with this other than to bring those two terms together. There's only a lone k, there's a lone 2, and there are a couple of root 2k's. So root 2k plus root 2k is 2 root 2k is just like 1 kitten plus 1 kitten is 2 kittens. And this is over k minus 2. And although it looks really tempting that you might want to simplify that, there's only one factor on the top. It's a complicated factor, but there's only one factor on the top. And there's only one factor on the bottom. And the only way you can cancel a factor is if... The only way you can cancel anything is if the thing you cancel is a factor of the top and of the bottom. Is that good? Okay, do me a favor and close your books. And you can use a calculator and something to write with. Have a 10-minute quiz here. Sorry for anybody watching the video. I just realized that my mic was off for the past couple of minutes, so I've just turned it back on. The steps in solving these radical equations are to, first of all, isolate the radical, and that's what we've done here. What's the second thing? Square both sides. Why? Why do you suppose squaring both sides is the next logical step in trying to get x by itself? Isaac? Perfect way to put it. Squaring and square rooting are inverse operations. They undo each other. You know, we can verify this. You should already know this, but if I ask you on your calculator to figure out what the square root of 10 squared is, and you take the square root of 10 and then you square it, you're going to get 10. Because really the square root of 10 quantity squared means root 10, and we know from work this year and last year that that means root 100. It's not a surprise that 100 is a perfect square because it was 10 times 10. So the square root of that gives you 10. In other words, and we don't want to have to go through that thought process every time, when you square a square root, and I think the brackets are necessary. They're not actually necessary on the left-hand side, but it helps drive the point home. When you square the left-hand side, you're just left with 2x minus 1, and this is equal to 49. And I hope you remember my philosophy in working with algebra in high school math. You take algebra at a higher level, you apply something to it to turn into algebra at a lower level. This, honestly, I think if I gave this to the class and I just walked in at the beginning of the class and said, solve that for x, I think some of you would get it right away, but many of you would be working on it for a long time because it's new to you, right? This is a Math 11 problem, 20-1 specifically. This, man, I don't know. Maybe grade 6 is pushing it, but it's definitely not even a high school math problem anymore. It's junior high. So how do you solve this? You add 1 to both sides, and you get 2x equals 50. You divide both sides by 2, and you get x equals 25. Now, that's the solution we suspect. But we always have to check. This is the most important thing about radical equations. We have to check that, and the way I'm going to ask you to check it is very specific because we use the same idea in Math 30 with other areas. We're going to look at left side and right side of that original equation separately from one another. There's no equal sign here. I'm simply going to take 5 plus root 2x minus 1, and I'm going to replace x with the number that we think is the answer, 25. So I'm going to get 5 plus the square root of 2 times 25 minus 1. And that becomes 5 plus the square root of 49, which is 5 plus 7, which is 12. And the right-hand side of the original equation was 12. What does that mean? It means that when x is 25, the left side does in fact equal to the right side, and what that means is x equals 25 is an answer to the question. And I suspect that many of you are going, how could it not work? Just hang on, because we'll see cases where it doesn't work. Any questions with example 1? Yep. No. Because you've hit on why there can be answers that are wrong. I want to make sure before I delve into this, because it's a complicated thing, if you're asking, do we not go plus or minus root 49? So that's a great question, but the answer is no, because there is no plus or minus in the question. If you remember, I've always been very careful to say, you put plus or minus when you introduce the square root. So if I had, for example, Ariana, p squared equals 49, and that's what you were looking at. and I said solve that, which by the way is quadratic, you're going to get plus or minus 7 because you've introduced the square root. Okay. But in this particular question, this is the equation right up here. This whole thing is the original equation. The square root is already there. And it does not say plus or minus. So no, and that's very important that we don't include plus or minus. Does that answer it? Okay. Any other questions with example 1? So we get 25. We do have to check that answer. Go ahead.
What if it was a certain type of question where the negative and the positive of the number both work in the equation?
Can you repeat that, please?
What if you solve the equation, both the negative and the positive give you the correct answer?
Are you saying you solve the equation and get 2 answers? And each of them work? Then if each of them work, like let's say, we're going to see this in a bit. When you square both sides, let's imagine that instead of getting this when you square both sides, this, by the way, is a linear equation, isn't it? From grade 10. Linear equations have one solution. I want to make sure I understand what you're asking this time again. Are you saying if when we square both sides and solve the resulting equation, we get 2 answers? Okay. That would mean when you square both sides, you get a quadratic equation. Because that's the only way you can get 2 answers. So you would solve the quadratic equation and you would get 2 answers. And it could be that both of the answers are correct, because when you put the first answer into the original equation, it's true. And when you put the second answer into the original equation, it's also true. It could be that only one answer is correct, because when you put one in, it works, but when you put the other in, it doesn't. It could be that neither of the 2 answers are correct, because each time you try them, they don't work. Does that answer your question? Okay. I would go so far as to say whatever equation results by you squaring both sides, I don't care how many answers come out of that equation. 1 or 2 or 3, which you would learn about in Math 30, or 4 or 5 or 6, or an infinite number. You have to check all of them in the original equation to find out which ones are answers and which ones we're going to say, no, that's not an answer. In which case, the one that is not an answer is called an extraneous root, which is kind of silly because root means solution. It's not a solution. It just doesn't work. Let's move on to the second example now. Negative 8 plus root of 3y over 5 is equal to negative 2. So what we're going to do is isolate the radical. I would recommend adding 8 to both sides here. And that gets us to the stage where we have the square root of 3y over 5 is equal to 6. When I square both sides, what happens? On the left, I simply get 3y over 5 because squaring and square rooting are inverse operations. They undo each other. Equals 36. By the way, since our y is raised to the 1, this is a linear equation. We're going to get one solution. I can multiply both sides by 5 to get rid of the 5 on the bottom. And I can divide both sides by 3 to get rid of the 3 on the top. I'm not a real fan of dividing by 3/5, but you could do that. You could say, I need to get rid of the 3/5 in front of y. I need to divide by 3/5. But you have to multiply by 5 and divide by 3, and I believe you're going to get 60. Yes? Okay, now a shroud of mystery surrounds this number. is it an actual solution? And I know, again, that you're sitting there going, how could it not be a solution? We haven't done anything wrong. Well, I believe it's going to be a solution, but we have to check, because it's not always going to be a solution. So we go left side and right side. The right side is, well, we don't have to do anything. It's -2. The left side is -8 plus the square root of 3 times y, which is 60, divided by 5. -8, let's see, plus 3 times 60 over 5 is 180 over 5 is, I believe, 36. I'm seeing some nods. So again, going to Adriana's question, because it says plus root, it means plus the principal square root. It doesn't mean plus or minus. Did I just call you the wrong name? Did I say Adriana? I apologize. Because of Ariana's, question, we have to consider that it's not plus or minus. It's just plus, because that's what's in the equation. By the way, had the equation, everybody, and don't go messing up your note package, but had the equation been this, then it would be minus here, right? Well, that's -2. Jackpot. Left side equals right side. So what you end up saying, once you've determined that the left side is in fact equal to the right side for y equals 60, is you say, well, yeah, that's an answer. Good. Any questions with number 2? Okay, n minus root 5 minus n equals -7. So we have to isolate that radical. I think you know my philosophy by now regarding terms that are going to be isolated. I would rather isolate a term so that it's positive than isolate it so that it's negative. So right now it's -1 root 5 minus n. I'm going to add that to the other side to get positive root 5 minus n. And this will be equal to n plus 7 when I add that 7 to the other side. So now what I need to do is square both sides. Of course, on the right-hand side, what happens is you're just left with 5 minus n, because squaring and square rooting undo each other. And I want you to write down what we get when we square n plus 7. I have this dream where everybody in the class writes n squared plus 14n plus 49, and nobody writes n squared plus 49. But I know that some of you probably wrote n squared plus 49. I know from experience. Don't forget that n plus 7 squared means n plus 7 times n plus 7. Which, foiling it out, distributing everything in the first binomial with everything in the second, gives n squared plus 14n plus 49. The resulting equation, and I'm really glad that Ariana did ask that question earlier, the resulting equation here is quadratic. You know how to solve quadratic equations, and you know from experience that they could have 0, 1, or 2 solutions. Let's find out what this equation has for solutions by zeroing the equation. I'm going to zero the equation by moving everything to the left-hand side, which involves adding n to both sides, resulting in 15n on the left-hand side, and also by subtracting 5, which gives me 44 on the left-hand side. Double check your arithmetic. 49 minus 5 is 44, definitely. 14n plus 1n is 15n. This is a simple quadratic equation which we're going to solve by factoring. I call it simple because the coefficient of the leading term is 1, which means all we need to figure out is the answer to this question. What two numbers multiply to give 44 and add to give 15? I think 4 and 11. So plus 4 plus 11, which means that n plus 4 can equal 0, n plus 11 can equal 0. So here you go. Look at everything on the left-hand side of the screen right now and ignore the squared part. In other words, if we look at the original question, that's a Math 11 question. It turns into it's a Math 11 Unit 5 question. It turns into, after we square both sides, a Unit 4 Math 11 question. And then, after factoring it, it turns into something, I would hope if you explained counting to anybody who understood negative numbers, they could answer this question. Right? Like if you could somehow convince a grade 1 student that negative numbers exist, they would understand the answers are negative 4 and negative 11. It's very simple, in other words. So n equals negative 4 and n equals negative 11. Now let's go to the check. Our original equation is, and we have to go with the original. Like I'm very serious here when I say you do not even want to use this. Don't use that equation because that is already the start of rearranging the original. It has to be the original, which is n minus root 5 minus n minus root 5 minus n. I'm just going to write the original equation here, equals negative 7. So let's do the negative 4 first. We have left side and right side. Well, the right side is really easy, so in retrospect, I'm going to just give myself a little bit more room on the left. Right side is negative 7. I need to take my n, which is negative 4, and put it here, and this should be an n, shouldn't it, instead of 9? N, 9, kind of sound the same. I think that's what my brain actually did. So we need to put that n equals negative 4. We need to put this in here and here. So we're going to get negative 4 minus the square root of 5 minus negative 4, which will give us negative 4 minus the square root of 9. Okay, so it's minus in front of the square root. It's not plus. We have to go with what the equation said. So this is negative 4 minus 3, which is negative 7, which makes us, well, as happy as you can be in solving a radical equation in the last period of your grade 11 math class. Makes us happy. Left side equals right side. What does that mean? It means that n equals negative 4 is an answer. Okay? What about if we try negative 11? Well, again, the right side is negative 7. There's no work for us to do there. The left side, we're going to put the negative 11 in here and in here. And I'm going to have negative 11 minus the square root of 5 minus negative 11. This is negative 11 minus the square root of 16, which is negative 11 minus 4, which is negative 15. Like, we did not do anything wrong. We didn't make a mistake in arriving at negative 11 equals an answer. But that doesn't change the fact that negative 11 doesn't work. So negative 11 is not a solution. Negative 11 is called an extraneous root. What does that mean? It means it's not a solution. And you want to be careful here, because I'm going to end up telling you that on exams, sometimes I'm going to ask you to find the extraneous root, which is kind of weird. I'm going to ask you to find the solution that's not a solution. And you need to know that extraneous root is the one that doesn't work. Yep.
Is there a way to algebraically check, like, that you know that just because you got one that looks like it's extraneous, it's not just because you did your algebra wrong?
Are you asking, is there a way to determine if it's extraneous or not without substituting the number in?
No, like, if you did it algebraically, just, I don't know, I guess normally, you could, like, plug the number back in, and if you got, like, 7 equals 7, then you know you did it right, because that's, like, your way of checking it. So is there a way to algebraically check it?
So are you asking, is there a different way to check it? There is, but I would rather not talk about it. The way to check it, I'll maybe show you later. I don't want to teach it to the whole class. It's more of a Math 30 idea. Let me think on that, and I may show the whole class. It's not a difficult idea to check it another way. It really isn't. But it requires some knowledge of what radical functions look like, and you don't know what they look like as graphs. So right now I will say algebraically there is only one way to check it, and it's to do what we're doing. Okay. All right, let's take a look at the next one. Okay, well, we have to isolate the radical. I'm going to subtract 6 from both sides and add this radical, or the square root of 2m plus 3, to both sides. In other words, I'm just transposing the negative radical to the right where it becomes positive, and I'm transposing the 6 to the left where it becomes negative because it was positive. Now I'm going to square both sides. I think from here on in, for the remaining examples, we won't bother writing down our work to check. I think we can just check it on the calculator to save a few minutes. This is going to be m squared minus 12m plus 36. This is going to be 2m plus 3. So I got m squared minus 12m plus 36 by taking m minus 6 times m minus 6. I am just curious, how many of you don't need to write out m minus 6 times m minus 6 to get this? Okay. So you've either developed a pattern or you're actually seeing m minus 6 in your head. It is quadratic because of that m squared, so we're going to zero the equation. M squared minus 14m plus 33. Don't forget your equals 0. Are there two numbers that multiply to give 33 and add to give negative 14? Yep. Negative 11 and negative 3. So m is equal to negative 11. Whoops, my mistake. No. Don't jump the gun yet. I'm talking to myself when I say that. It factors into m minus 11, m minus 3, which means the two solutions are supposedly 11 and 3. So what I want everybody to do, we'll just say everybody to my left, over here. I want you to put 11 into the original equation on both sides if necessary and find out if 11 works. And everybody else, I want you to do that with 3 and find out if 3 works. Of course, if it were a written response question, you'd have to show your work. think 11 works. You're going to end up with the square root of 25, I believe. You'll have 11 minus 5, which is 6. Well, that's weird, isn't it? You get 0 on the left-hand side when you put 3 in. Well, 0 is not equal to 6, which means 3 is not a solution. It's extraneous. So, well, I'll pause there. Any questions with number 4? What if you have 2 radicals? Well, the equations that we have left in number 5 and 6 have 2 radicals, but that's all they have. And if you square both sides of this equation, then we're ready to rock in terms of solving the equation. Because if you square both sides, you simultaneously, in other words, at the same time, get rid of both radicals. So you're left with 3h minus 4 equals 5 minus 6h, and really you're left with a grade 8 or 9 equation to solve. I'm going to move all of my h's to the left-hand side to get a positive 9h. I'm going to add 4 to both sides to get 9. 9h equals 9 means I divide both sides by 9 and get h is equal to 1. And now all that remains is you have to put 1 in the left-hand side and 1 in the right-hand side and see if they're equal. That's pretty weird. So I'll ask you a question. Are the left and right hand sides equal when you put 1 in for h? You could argue that they're equal. You get negative 1 under the radical. But the square root of negative 1 doesn't exist. Which means we've got a value for h here that you're not even allowed to put in. So it's not a solution. You can't say the square root of negative 1 equals the square root of negative 1 because the square root of negative 1 doesn't exist. If you took math at a higher level, there's a deeper meaning to that. But this is not allowed. It's not even really that it's extraneous. You end up with something that's just not allowed. Final example is very similar to number 5, but we have to, so you're not isolating a radical, you're isolating both radicals. You're putting them on opposite sides of the equation. So if I have root 15k plus 4 equals root 11 minus 6k, I can now square both sides. What do I get? 15k plus 4 equals 11 minus 6k. That's candy stealing territory from a baby. Add 6k to both sides. After saying that, I'd better not screw it up. And get 21k equals 11 minus 4 is 7. K is equal to 7 divided by 21, which is a third. Does a third work? Well, I'm just going to do this on my calculator. Remember, we have to go to the original equation. So I'm going to figure out what 15 times a third plus 4 is. That's 9. So this is root 9 when I check it with k equals a third. Minus, when I put a third into 11 minus 6k, I'm going to get 9. Root 9. Is that a true statement? Is root 9 minus root 9 equal to 0? Sure. Because root 9 is 3. 3 minus 3 is 0. So this solution survives the investigation. It's a correct answer.